Hello, welcome back to this channel. In the previous video, we discussed the data communication network and the basic devices that are used to construct a data communication network. In this video, we are going to study the types of such networks as classified by their geographical coverage. We are going to talk about the local area networks, metropolitan area networks, and wide area networks. We are also going to discuss the different network topologies that can be used. By the end of this video, therefore, you will know the different types of networks and what exactly they are, the technologies that are used to interconnect those networks. You will also know the advantages and disadvantages of the different types of network topologies.
So let us start with the network types. And for the network types, we are really going to talk about the local area network that covers a small geographical area. We are going to talk about the metropolitan area network that covers a medium geographical area, not small, not too large. And we are going to talk about the wide area network that covers a really large geographical area. We are classifying types of networks based on geographical coverage. When you talk about a local area network, it is characterized by covering a few square kilometers. The main function of a local area network really is to connect several terminals that are close to each other. We are talking about the closeness of, say, within a family, say within a campus like Chambogo University, something like that. There are several technologies we use in local area networks, but the most common ones we have is Ethernet and Wi-Fi. These two are the most common ones deployed on local area network. This one for wired local area network, this one for a wireless local area network. All right. The second type of network I want to mention is the metropolitan area network. The metropolitan area network is a bit large. In fact, it covers something like the size of a city. It's a large-sized local area network, really. It requires high costs, but it can provide higher transmission rates. The metropolitan area network improves the transmission media in local area networks and also expands the access scope to be able to cover like a university campus or an entire city. We are talking about a really huge university campus here. The main function is to connect hosts, databases, local area networks in different locations. I want you to notice one important thing, that in a metropolitan area network, you're going to actually be connecting a number of local area networks. The main function of a metropolitan area network is to connect things like databases, web servers, to local area networks, to hosts in like the same city. The technologies we use for metropolitan area network are Ethernet for wired metropolitan area network and what we call WiMAX for wireless metropolitan area network. Here I said Ethernet for wired and Wi-Fi for wireless. Now, of course, there are other technologies, but those are the main ones. Now, when you talk about the wide area network, covers a large geographical area, covering tens of square kilometers to even thousands of square kilometers. It can connect networks of multiple cities or even networks of countries, provide long distance communication, and the internet is a typical wide area network. The technologies we use in wide area network include point-to-point protocol, and they also include these things like 2G, these things like 3G, these things like 4G LTE, these things like 5G, these things like upcoming 6G. Now, all these ones are wireless wide area networks. This is for a wired wide area network. So these are the types of networks, and in this slide we try to give you the relationship. You can see we have a local area network for a college or university and another local area network for a college or a university, and connecting different local area networks of colleges or universities give us a metropolitan area network. You look at also local area networks of school and what, giving us a metropolitan area network. And then metropolitan area network and metropolitan area network and metropolitan area network give us a wide area network. This kind of drawing is exactly what we call a what? A topology. It simply shows the physical layout or the structured layout presented using transmission media, how you're connecting your devices like twisted pairs or optical fiber to interconnect various devices like computers, like routers, like switches. These kinds of drawings are professional drawings, and we use them to describe the physical or logical structure of a network in this field or the network engineering field. It is a very important network engineering concept. It is actually very important to master professional topology drawing skills, but this requires lots of practice. In the professional realm, we normally use MS Visio or MS PowerPoint to do network topology drawing. Let us talk about the types of network topologies. There are a number of network topologies, but really to get the idea is just to look at the arrangement of the devices. You realize in this kind of arrangement of devices, it is some kind of star. There is a hub in the middle, which could be a switch, and then devices connected to that switch. It looks like a star. All nodes are connected to a central node. Now, there are advantages to this because it is very easy to add a new what? A new node. You don't interrupt anything if you want to add a new node. Communication data must be forwarded by the central node. When you forward everything by the central node, it is easy for you to do what? To monitor and even control. The problem with this topology is that if the central node gets a problem, then you don't have any network, right? The second topology we have here is the bus topology. And as you can see in this topology, it looks like every network node is being connected to a central bus. All traffic is going to be carried by this central bus. Could be a coaxial cable, for instance. The advantage with this topology is that the setup is simple and there are few cable resources used. Generally, the failure of one node does not affect any other nodes in the entire network. But the problem with this setup is that if the bus gets a fault, then other nodes are going to have a problem. The information sent by a node can be received by all other nodes in this kind of network. The other that we want to talk about is the ring network topology. And as you can see, they are really organized in a structure of a ring. And each node is connected to two other nodes in the network. And as you can see, there are fewer cable resources used. That is an advantage. The problem with this ring topology is that it is difficult to add another node. Let us say I wanted to add a sixth node. It usually means that I have to disconnect one of these points to add my node and add the cable. So I can't add a new node without interrupting services in this ring topology. The other topology is the tree topology. Now, the tree topology is a really good one because it is a hierarchical topology. Being hierarchical has a number of advantages, and one of them is the fact that it facilitates network expansion. You can just add, new nodes at the bottom of these. It facilitates network extension. It is a hierarchical star in structure. You see, this is a star, but also this is a star right here, and this is a star. So it is hierarchical. Multiple star networks can quickly be combined, so it facilitates network expansion. However, there is a very huge problem with this topology, because if a problem occurs at a higher node, the effect is going to be severe. A problem occurs at this node, the effect is minor. But if the problem occurs at this node, for example, then you have no network. So the other one is the full mesh topology. In this case, all nodes are interconnected to all other nodes through cable. And as you can see, there is too much cable resources that are used, in addition to each node requiring really many ports to have all the interconnections. Each node requires many ports to have all this kind of interconnection. But the advantage is that this is the topology that has highest level of reliability. It's very, very, very reliable. Because if node 1 wants to talk to node 4, it can pass via this link, and if this link is faulty, it can use this link. If this one is faulty, it can use this link or this link. All these links can still lead to 4. That's what we call reliability that comes out of redundancy. But as I've mentioned, each node requires a large number of physical ports and interconnection cables. As a result, the cost for this type of topology is really, really high, and it is even difficult to expand. The other topology is the partial mesh topology, which has part of the advantages of the full mesh topology. Only key nodes are interconnected in full for this one. Only key nodes are fully interconnected with cables. The advantage is that it picks part of the advantages of this, but also reduces the cost of full mesh. So there is a high reliability in the interconnected nodes, but at least the cost is going to be lower than this one. But also in the same way, there is high resources that are used. So in other words, what we are trying to say is that the resources in the partial mesh topology are less than the resources in the full mesh topology. The disadvantage is that reliability of a partial mesh is also going to be lower than the reliability of a full mesh. So those are the different network topologies.